Okay, and looking at the last two transformations, we'll talk more in depth about these later, but just right now, just so that you know, a transformation that's a reflection is a flip. You can remember that because you've got the FL in there. Reflection, it's a flip of a figure. It can be flipped to the side, up, or down. The figure has been flipped horizontally over the dotted line. So it's been flipped over the y-axis. Your shape is either going to flip over the y or the x-axis when we talk about them. And so we're going to identify if the congruency is preserved, if it's the same size, same shape, and if the orientation changes or is preserved. So state if the figure below represents a reflection by writing yes or no. So number 1 is going to be a reflection, because it's almost like this is a mirror. Like this shape is looking into a mirror. It's the same thing, it's just completely flipped. It's the mirror image of it. And since it's a reflection, is the congruency preserved? Is it the same size and shape from the pre-image to the image? Yes. So it's congruent. And does the orientation change? Yes. So if the black dot here is facing to the right, and here the black dot is facing the left. So the orientation changes. It's congruent, orientation changes. Then B, is it a reflection? Yes or no? Yes, it's a reflection. Because remember, see it as a mirror. See this y-axis, this is your line of reflection. It looks like a mirror. And from your pre-image to the image, is it the same size and same shape? Yes. It doesn't get bigger, it doesn't get smaller. And does the orientation change? Yes. Pretty much anytime you have a reflection, the orientation is changing. Just remember that. C, same thing, it's kind of hard to tell. I guess it could be a translation, but just for the vocab purposes, we're going to say yes, it's a reflection. And does the size change? I don't think so. It doesn't look like it. So it's congruent. Anytime you have a reflection, the size is not going to change, but the orientation will change. And even though I know the shape is hard to tell because it's not labeled, but if you have a reflection, the orientation is changing. Same thing with a rotation. Rotation, think about rotating your tires. Rotate, it's a turn of a figure. The tire can be rotated any number of degrees. So it can rotate 90 degrees, 180, 270, and we'll talk about that later. 360, if it rotates 360, then it just ends up right back in the same spot. But for right now, we just want to identify if the congruency is preserved. So does the second shape keep the same size and shape, and does the orientation change? So does it start facing a different way after it's been rotated? So like this little example here, it turns. So it's the same size, it's the same shape, so it's congruent. But our top of the triangle was facing up, and after it changes, now it's facing to the right. So that's what I mean when I say the orientation changes. It's facing a different direction. So down here at the bottom, the figures below represent a location by writing yes or no. And number 1, we're going to say yes. It's a rotation. It turned. So is the congruency preserved? Is it the same size? Yes. Congruent. I'm just going to abbreviate it. And does the orientation change? Yes or no? Yes. Because our arrow was pointing down. Now it's pointing to the left. It's congruent, and the orientation changes. On B is really a reflection. So I'm going to say no, that it's a reflection, but the same rules apply. Okay, so A reflection is going to be congruent. Your second image's size doesn't change, but it's facing a different direction now. So the orientation changes. And C, this is, yes, a rotation, but the size doesn't change, I don't think. I know it kind of looks a little different, but for rotations, the size shouldn't change. So it should be congruent, and the orientation changed. So just remember that rotation and reflection, they're always going to be congruent. The size does not change. The orientation does change though. So down at the bottom, identify each statement as true or false. If false, explain why. A says orientation, so that's the direction the shape is facing, is generally preserved for reflections. What did I just talk about? False. Reflections and rotations always change orientation. So reflections and rotations always change orientation. The congruence, so remember same size, same shape, is preserved for rotations, reflections, and translations. Part of that's true, part of that's false. So I'm going to say false. Oh, wait, nope, just kidding. I'm going to say true. It's all true. Sorry. Congruent, so same size and shape. If you rotate it, you're turning it, but the size doesn't change. If you reflect it, you're flipping it, but the size doesn't change. Translating it, you're sliding it on the coordinate plane, but again, the size doesn't change. So that is true. So sorry. And on C, orientation. So that's the direction it's facing. The orientation of the vertices. So vertices just means if you have a shape, vertices is those little corners where they meet. The orientation of the vertices is preserved for translations, but not rotations. That is going to be true. If we slide this shape down, our vertices are still going to be facing the same way. If I take this triangle and I look at those vertices, A, B, C, we'll say, and say I turn it 90 degrees, now I've got A up here, B down here, and C over here. So the direction of those vertices is preserved for translations, but not rotations. So that's true. This preserves the orientation, this does not. On your worksheet, just read really carefully. Remember, rotations, reflections, those are gonna preserve congruence, but not orientation, unless, think about if you get to number 5. If you turn around 360, if you do a 360, are you facing the same direction or a different direction as when you started? So think about that. Dilation, remember, is the only one that'll change congruence. It's the only one that changes size. But again, just be really careful and think about if you dilate something by a scale factor of 1, what's actually happening to that shape. Then on these, write an algebraic representation that shows the shape is dilated by a scale factor of 7. Okay, so algebraic representation for dilations looks like this. So it starts with regular x, regular y, whatever it may be, and it's going to be dilated by a scale factor of 7. So that means you multiply 7 by your x, you multiply 7 by your y. Okay, so this would be your answer. And that's what you're going to do for all of those other ones.